All right, let's talk about intramolecular forces. Now, along with intramolecular forces, you're also going to hear intermolecular forces. And these two are different. As similar as they sound, they are two different things. Now, intermolecular forces are the attractions that exist between different molecules. So, for example, if I have, let's say, HCl, and I have another HCl, there are some interactions that exist between these two different molecules. That would be, or this here, is an intermolecular force. However, the bonds that hold a molecule together, so the bond that's holding the H and the Cl together, this is what we call intramolecular forces. There's a few different types, and we'll learn all about those soon. Here's another visual that sort of shows the same thing. Here you have a bunch of water molecules, and you'll see that there is some attraction that exists between the water molecules. And these are known as hydrogen bonds, and they are an intermolecular force or an intermolecular bond. And what's keeping the water molecules together is an intramolecular bond. Okay, and we've talked about some of these intramolecular bonds already, or intramolecular forces already, but let's sort of recap them all again in the context of what an intramolecular force is. So there are four main types that we're going to talk about today, and these are ranked in the order of strongest to weakest. So starting off with one that we probably haven't heard about before, this is metallic bonding. And before we get into what it is, I'm going to show you a visual just to sort of explain or have you start thinking about what metallic bonding is. Now, this is not bonding in the traditional sense, right? It's not an ionic compound or a molecular compound like we've talked about previously. This is just referring to how different metal atoms are held together. So imagine that you have seen a block of gold, right? There's nothing in that pure gold block except for gold itself. And if that's the case, the bonding that exists there looks a little bit like this. Okay, so let's go back. So metallic bonding is how metals are held together. And you have in there a bunch of different atoms. I'm going to go with that gold example, a bunch of different gold atoms all stacked up right next to each other. And they're so close that what ends up happening, is that the electrons of that one gold atom, and all of those gold atoms, are able to move freely between the molecular orbitals, right? So those electrons are able to detach from its parent atom. And when that happens, the electrons are called or said to be delocalized. That means that these electrons are going to move away from its parent atom and are able to move enough so that it forms an attraction between the nucleus of this particular atom. And then maybe this one can move over so that it can form an attraction between that atom. So it's essentially the nucleus of those atoms, because they're held so close together, the nucleus of one atom is attracting the electrons that are delocalized within that particular metallic bonding situation. So if you're talking about a block of gold, right, those electrons are kind of delocalized in there. So the metal is held together by the strong forces of attraction between the positive nuclei and the delocalized electrons. And because of this, you end up with a very strong intramolecular force. Okay, so that was the first intramolecular force. Let's go into something that we have seen before. And you might not have seen it phrased this way, but it's electrostatic attraction. And this is the intramolecular force that holds ionic compounds together. And when you think of an ionic compound, let's say, for example, we're thinking of NaCl. In our mind, it might exist as one Na ion and one Cl ion. But that's not actually the case. They exist in a lattice structure. And I can show you a picture soon enough. But it's not just one Na ion and one Cl ion, but several different ones that are arranged in a very, very specific structure, right? And because it's not just one or two ions, there's a bunch of them held together. There's a lot of energy that's required to break it apart, right? So each ion is strongly attracted to all the adjacent ions of the opposite charge. So if you take a look here, the blue is supposed to represent the sodium cation, and the yellow is supposed to represent the chloride anion, right? And they're arranged in such a way. So this particular chloride ion is attracted very, very strongly to all of the blue sodium ions that it's right next to. And because there's such a large number of these ions arranged in this manner, it takes a lot of energy to break them apart. And when we look at properties of ionic compounds later, you will see that this particular attraction, these electrostatic attractions, play a huge role in the properties that we observe for ionic compounds. All right, moving on to the third intramolecular force that we're going to talk about. Something that we're quite familiar with is polar covalent bonding. So this is a bond that exists between two nonmetals. And in this particular bond, in a polar covalent bond, the electrons are shared unequally. And as we've talked about previously, this unequal sharing results from the fact that there is a difference in electronegativity. And this electronegativity difference allows for the electrons that are shared in that one bond to hang out a little bit closer to the more electronegative atom. So if you're looking at an HCl bond, the electrons are going to hang out a little bit closer to the Cl because it is more electronegative, right? So polar covalent bonding occurs between two nonmetals, and it is unequal sharing of those electrons in that bond. And lastly, we're going to talk about nonpolar covalent bonding. And this is very similar to polar covalent, but the key difference is that there is unequal sharing of electrons. It's still between two nonmetals, but in this case, the electrons are going to hang out closer to the middle because the electronegativities of the two atoms that are involved in this bonding are, if not the exact same, they're close enough that the electrons are able to be shared equally. Okay, so an example, if you have two Cl atoms that are forming a bond, those electrons are going to hang out exactly in the middle because the two Cl atoms have the exact same electronegativity. All right, so those were the four intramolecular forces. Let's see what the intermolecular forces are in the next video.